In this video, I'm going to show you an example of how you can investigate downtime losses associated with machinery or a production line using Epicor Data Analytics or EDA. And the source of the data is through advanced MES, also known as MATEC. So let me switch over to EDA. So what I'm showing here is an example dashboard of an all-plant dashboard. And in this example, we can see OEE is well below our target. And a quick glance along here, and we see that availability, which is percent uptime, right? So really an uptime downtime factor is showing low at 77%. So in this scenario, if I'm a system plant manager, ops manager, even department manager, I may be looking at a dashboard like this that may only represent a day, it may represent a month, it may represent 3 months. We're going to play this out such that I'm going to use enough data that I'm looking at chronic losses or reoccurring problems that I'm having related to the downtime. So with that availability and that focus, instead of drilling in here, we've got a lot of dashboards. And if you were participated in the review of the PowerPoint that I showed earlier, I had shown some examples of these dashboards in that deck. And here what we're going to do is pick this particular downtime dashboard. Now this isn't going to default to the same time frame, but I'll set that up. What's nice about a dashboard like this, which is focused, pre-configured and focused only on downtime, is I can look at things like the number of occurrences. I can choose many different types of charts for visibility and comparison. The top 5 downtime codes, the downtime reasons, total hours is in here by machine, if you notice. As we scroll down, we have some dual axis charts that are comparing current and previous, and a downtime cost factor that was brought into this database so that when this dashboard was created, a widget specifically here, somebody could be able to compare those two factors. We're going to look at this top 5 downtime reasons and dig in and again use this as an example about how we could use this powerful EDA tool to be able to isolate to potential issues in the manufacturing plant. So across our operation, we really don't even have a legend here, right? So let's drill in and see if we can even find the legend. It just simply can't fit with that much space. So what we do is we've defaulted to a table view, but if we wanted to go back and look at that same chart view, we can just click up here in the top right, and now you see the same chart view. And because we have a lot more space here, the automatic resizing does allow us to actually show the reasons we have in here. And we actually see that the number one reason across our plant is scheduled downtime, which is not a concern, right? This may be due to lack of demand. We've got idle assets, idle machines, so it's not scheduled to begin with. But then if we look next, we see none. Okay, we're going to talk a little bit about this none as we go into and try to isolate versus all these other individual reasons that have been coded, also known as tagged when we talk about that. Let's go back to the table view to be able to do some comparisons. First thing that we're going to do here is change it to a 3-month trend or 3 months of data. And why are we doing that? Because maybe 1 month just isn't enough data to say that it's enough data to be able to predict the future. So it's a balance between you don't want to get too much data that you're having old data and problems are gone, but you want more recent data and enough data so that some level of outliers aren't necessarily affecting the overall assumptions that you're making or predictions that you're making. So we'll change our period to the last 3 months or a custom. We can set it up custom, but since we have this shortcut, amongst other things, we'll pick this one. And we're going to default to this April through June period. Now, if you notice, I went into a widget that told me about the number of occurrences, and look at these big numbers, 75,000, 57,000. Now, is occurrences really what you're going to focus on? It's important to a certain extent, of course, and that's a whole nother discussion. But really, when we talk about downtime and we talk about the effect in OE, we're really talking about time, right? Hours lost, et cetera. So we can go up there and use this measures because we've got other items that were set up in the database so that and there could be a lot more items in the advanced MES database, but what we've shared and pushed to be able to create this dashboard are just these 5 items from the database. So we're going to pick down hours and oops, excuse me. So now with the down hours, let's sort on that. And we can see that none pulls itself right to the top at 938 hours, and then followed by a setup, right? So it could be a changeover, et cetera. So this is not a good story, right? I got 938 hours of downtime across my plant, and I don't know where's it at right now, and even what the reason that I have this downtime. So I'm really interested in this, and I'm going to dig in a little bit deeper to see if I can isolate to where is it a department, is it a machine? What's going on that we've got a lot of downtime and we're not actually having operators put in the reason, or we're not capturing automatically, since the system could do that as well. So what we're going to do is we're going to select this none and we're going to focus on it, and just to be able to look at that and do some research. Now I'm going to show a little bit of different tool versus just the focus and the drill in that, and that really is called a nesting, and this plus or minus sign up here will allow me to do that. So the nesting is kind of nice because I can kind of build and expand and see where my issues are. So what we're going to do is we're going to pull up machine, because we're trying to now isolate. We go to department, but let's just go to the machine level and see if we can isolate where this coding issue is, lack of coding. So I was going to machine, and let's do a sort again on downtime hours. And we very quickly learn that this AINJ02 machine is dominating, 853 hours out of 938 total down hours across the plant for this time period. And it's all coming from this machine for the most part, for the none, excuse me, the tags that are no downtime, no downtime reason. Just expanding is going to show that down code that we already selected and isolated. We can also take a look at the shift, because that's logical if you think about it. If you got a coding issue, lack of coding, then potentially it could be driven not just by the machine, as we found, but also within a shift for that machine. Let's drag that up. And we'll expand this so we can take a look at the day-night. And what we do is we can see that they're relatively the same. So it's not important, and it's not affecting it. Whenever we find data that's not affecting our outcome, we're just going to get rid of it because it's noise. It's visual noise to us. So really what we're at this point is we've learned very quickly, we've learned that we've got a lot of untagged downtime across the plant. We're able to isolate it so that untagged or uncoded downtime, a good 90% of it or so as an estimate, is coming from one specific machine. And that's our action plan at that point, right? And that is that we need to potentially go out and talk to supervisors, go out and talk to operators, find out what is the problem? Why aren't you coding? I mean, it could be the way the system is set up that they can't do it, or they're just not held accountable for it. And then we can take action and start to get meaningful data into the advanced MES MatTech system that we can then more readily evaluate and prioritize using this EDA tool. Thank you for your time.